All right, and here is our last one for this lesson, determining the number of solutions of an equation. Number one, how many solutions does the equation 2 up against 2x minus 10 minus 8 equals negative 2 up against 14 minus 3x have? So what we have to do is we have to distribute on both sides the number outside of the parentheses to the numbers inside the parentheses. So 2 times 2x is 4x. And then 2 times negative 10 is negative 20. Bring down what we haven't touched. 2 times 14 is negative 28. And, and negative 2 times negative 3x is positive 6x. And then we're going to simplify or combine like terms. Here we'll have 4x minus 28. And then we have minus 28 and 6x. All right. So then we're going to continue solving. Plus 28. 4x is going to be equal to 6x. The only way this is going to work, similar to the last page, is if x equals 0. It's the only way we're going to get a true statement here. So that's exactly one solution. Moving on to number 2. How many solutions does this equation have? Same thing, since we can't distribute, we're just going to go ahead and combine like terms. 10 minus 7 is 3. Negative 3x plus 10x is 7x. All right. 5x plus 2x is 7x. And negative 5 plus 8 is 3. If you notice, your constants are the same, your variable terms are the same. Every term matches. When you have that, you've got infinitely many solutions. So we've got D. Okay, moving on. So we're matching which one is still the same thing as 1 and 2, but we're just shading in the box that it goes with. So looking here at the first one, we've got the same coefficients but different constants. When you have the same coefficient but different constants, that's no solution. Okay. The next one, we've got negative 3x minus 17 equals negative 17 plus 3x. You have to distribute your negative. So you really got negative 3x plus 17, negative 3x minus 17 equals negative 17 minus 3x. You've really got the exact same thing on both sides. That is infinitely many solutions. Okay? You got all the same terms on both sides of the equation. All right, moving on to the third one. We've got 9x plus 27 equals 27. We can go ahead and subtract 27 from both sides, and then you'll have 9x equals 0, so x will equal 0. That's exactly one solution. And then we've got our final one. So we've got the same variable term, but different constants. When you have different constants, that's no solution. Okay. Moving on to number 4. Which equation has an infinite number of solutions? Select all that apply. So again, infinite number of solutions, when you simplify it all the way down, then you should have the same variable term on both sides and the same constant on both sides. All right, so simplify it down as much as you can for each problem. All right, so then I'll have x minus 10 equals x minus 20. That is not a true statement, it's false. So I'm not going to get this to be infinitely many. B, moving on, I've got 5x plus 2x minus 6 equals 5x plus 6 minus 2x. I've literally got the exact same thing going on. Or never mind. I got confused for a second. So I've got negative 2x and a 5x over here. So I've got 3x plus 6 equals 7x minus 6. It was very close because of the 2x's, but they are different. So this will end up giving me one solution, which is not what I want. C, I've got, I don't have to do anything to those, but what I could do to make sure that I don't have anything is I can see that my coefficient, or my constant is 3. So if I multiply everything by 3, I'll have 3x over 2 plus 3. Move this out of the way. And 3x over 2 plus 3 is not equal to 3x over 10 plus 3. So that also will not give me infinitely many solutions. Moving on to D. Simplifying again, keeping the left side the same. The right side, I just have to distribute. So I've got 9/2 x minus 2x minus 2. So I need to combine like terms on the right side. So 9/2 x is really 4.5x minus 2x. And that's equal to 2.5x, which is equal to 5/2 x minus 2, because I just dropped that down, is equal to 5/2 x minus 2, which is exactly the same on the left and the right. So D is one of my answers. And let's just see if E is also one. Oh my goodness. Okay, this first one, I was like, shouldn't make any sense. This first one, I actually made a mistake. It should have said 3x minus 2x minus 20. So then I would have had x minus 20 on both sides. So A is actually an answer as well. Okay. E, you can easily look at these, and you can see that they don't have the same. The left side literally doesn't even have a constant, so they can't be the same. Okay, so your final answers for 4 would have been A and D only. All right, moving on. 5. Consider this equation. 2 up against 5x minus 4 is equal to ax plus b. Find a value for A and a value for B so that the equation has only one solution. Remember, when it has one solution, the variable terms don't match. That's really all you have to look for. Okay, what I really like to do is not have my variable terms match, and then possibly have different constants, but that's the constant part is not mandatory. But it does make it super easy for you to see if it's one solution or not. Okay, so let's go ahead and distribute first just to make sure we get it right. So we have 10x minus 8 equals ax plus b. So let's just make sure we don't choose the same variable term. So for our a, it just can't equal 10. So our a cannot equal 10. That's pretty much how we can get this right. So just choose a number that is not 10. I'll choose 7. And then my b can actually be negative 8, but I'll just choose whatever number I want to for b. And I'm done. So b can be any number. A just can't be 10. All right, part B, find a value for A and a value for B so that the equation has no solution. When I have no solution, then the variable terms match. But the constants don't. Okay, so when I write down what I had again. Okay, so variable terms have to match, meaning A has to equal 10, but B cannot equal negative 8. So my A has to equal 10, but B Just can't be negative 8, so I can choose any other number I want. So I'll choose 6. Okay? And I've got no solution that way. If I see that, then if I plug that in, then I'll have 10x minus 8 equals 10x plus 6. So you see, it wouldn't end up equaling anything. You get a false statement. I get that negative 8 is equal to positive 6, which is not true. It's false. This is what we mean when we say no solution. And the final one for this lesson, find a value for a and b so that the equation has infinitely many. When we have infinitely many, then every single term matches. Okay? Every term matches. So again, just as a reminder, we had 10x minus 8 equals ax plus b. So our a has to equal 10, and our b has to equal negative 8. 10, negative 8. And we are done. All right, thank you.